What's up, Algebra 1? Wanted to do a video for today's homework, reviewing several topics from the past few weeks. A lot of the stuff we've been doing in class about linear correlation really requires a calculator, so I had you do some homework last night on that. But I want to continue to review topics that we've done in the past that I thought we were weak on at times. So let's jump into some sequence practice for the second term and the explicit formula. So we are going to first study it because we may think of it as geometric if it's not arithmetic. But this one is geometric because the second number minus the first number produces a value that seems to be consistent as the rate of change, or later we'll call it slope, between these values. There's a common difference of -6 between these values. So I want to start with my formula. A sub 1, that is 10. That represents the first number in the sequence. We are subtracting 6, and then n minus 1 is part of the formula. We need to distribute to clean this up. 10 minus 6n plus 6. Seeing a lot of mistakes in this step, not getting that sign to be correct as a positive, for at least for this problem. Negative times a negative is positive. And then combining like terms to produce your explicit formula. So now we want to use that value, use that formula to predict a future term in the sequence. So I'm about to plug 52 in because I want the 52nd number, but I do want to make sure we understand how the formula is connected to the sequence itself. -6n plus 16. -6 times 1 plus 16. First number is 10. Okay? That should work every time if you have the equation correct. If I was to plug in 2, -6 multiply 2 plus 16, you should see that +4, which is the second value. So first number 10, second number 4. Anytime you have the equation and you need the sequence, make n1, make n2, make n3. So the last thing we're going to do is we're going to plug 52 in. We want the 52nd term. So -6 multiply 52 plus 16. -6 times 52 plus 16. Making sure that all types out correctly. That gives you -296. So the 52nd term would be -296, just to make sure I got that correct. Okay, so I'm going to leave you number 2. Use the same process because both of these are arithmetic, and we'll check your work tomorrow. We're going to do a geometric next. So it says find the 8th term, and we're going to write an explicit formula to determine some future value, like the 8th term. So anytime you're not sure what you are multiplying by, take that second number and divide by that first number. So -18 divide -3, +6. So if you really look at these numbers, it's like you started at -3 and you multiplied by 6 over and over and over. Keep multiplying by 6, you keep getting bigger and bigger values, but you're also getting the values in the sequence. So again, just divide those numbers to see what you need. So the first number in the sequence is -3. That's what this part means, the first number. And then you're multiplying by 6, n minus 1. We now want to find the future term, the 8th term in the sequence. So we have our formula, but now we're going to use that formula to calculate some future term. So -3 times 6. And then I want to do the power as 8 minus 1. And so here is our new 8th term, -839,808. So I want you to think about this one, but I want you to really consider, how do you build the formula when you are clearly dividing? Okay? So I want you to think about what that should look like. And we'll check your work on number 4 tomorrow. So when you're talking about simplification of expressions, it's not that we're solving for the value of the variable. We're really just cleaning it up, making it look more compact, more smaller in a sense. So let's start with number 5 with multiplication. This is called distribution. Distribution is a form of multiplication. So -6 multiply 8, -48. -6 times 7b, -42b. And then that plus 1, I shouldn't multiply that by -6 because it's only multiplying what's in parentheses here. And that 1 is not in parentheses. So one of the reasons why I want to take time to demonstrate this is because a lot of times students struggle to put these values together because they think you should change the sign. You should only change the sign if you are solving and there's an equal sign in the problem and you're moving numbers across that equal sign. But in this one, -42b, that does not have a like term, but -48 plus 1, just to show you I'm not really changing those signs, -48 plus 1 is -47. So that's what I'm going to put. -42b minus 47. That's the answer. So I'm going to try 7. I'm going to leave you 6 and 8 to try on your own. I'm going to change colors. Multiplication, -5 times x, -5x. -5 times 2, -10. We're now going to distribute again, but we're going to use a different number. -3 times 3, -9. -3 times 10x, -30x. So now we look for like terms. And so I see -5x minus 30x. Again, I want to put those straight together. -5 minus 30, -35. Now notice I don't put x in the calculator. I am only using these coefficients, -5 minus 30. And that does have x with it on paper, but you won't put that in the calculator. -10 minus 9 is -19. This is the answer. We cannot go any further because these are not like terms. So I want you to try 6 and 8 in the same way. So what I wrote over here is kind of hard to read. This says opposite operations. The opposite of adding would be subtracting, and the opposite of multiplication would be division. I want to talk about that for just a minute. Like, why are we using opposite operations when we're solving? Solving is basically your mission is to determine what number should replace the variable to make it true. So what number plus 2 is 3? Well, maybe you're thinking 1. 1 plus 2 is 3. And I would say, yeah, you're correct. But to solve for that, I would have to undo the way that that would work and use subtraction to determine, like, oh, well, 1 plus 2 is 3, just like 3 minus 2 gives me 1. And so similarly, if I was using multiplication, like 2x equals 10, again, multiplication is in algebra when they're against each other. I would use the opposite of multiplication, division, in order to figure out that 5 multiplied 2 is 10. So that's kind of the short and skinny as to why you would change the operations, but it's only when there's an equal sign, and it's only when the directions are solve. Pay close attention to the word solve versus the word simplify. Those are not the same thing. So I want to start kind of like on the section above it. I want to distribute my -7. 8 will not change. I don't need that number to change. But I really need to multiply -7 into this parenthesis and be careful with the negative times a negative, making positive 28. Well, now I'm looking for like terms that are on the same side. For example, 8 plus 28. Those are like terms. And 8 plus 28 makes 36. So I want to keep -7b, but I want to simplify that left side like an expression simplifies by combining 8 and 28. Well, now I need to know, well, what number plus 36 is 92? So that's why we would use subtraction to kind of undo the process a little bit in order to figure out what the value of this b variable is. So 92 minus 36, it's been a long day, I can barely even think. 92 minus 36, that is 56. And now, again, when you see things that are up against each other, negative 7b, those numbers are multiplying together. So I want to use division to figure out that b has to be the value negative 8. So if b is negative 8, there's a way to check to know that you did this problem correctly. And what we need to do back in the problem and replace b with negative 8. And if it's correct, it should calculate 92 when we do it. So 8 minus 7, parenthesis, and this is where the x comes in, or b rather, negative 8 minus 4 in the parenthesis. And so this is just a real fast way to know that that is correct. See, it says it's 92, and that's what I wanted it to be, 92. And so that's really what solving is, finding that number that makes it all work. So you try 10 on your own, very similar problem. I'll do 11, and you can try 12. This is what we call variables on both sides. We have a variable on the left, we have a variable on the right, and our goal is to get m equals a number. And m doesn't have to be over here, it could be m equals with a number over here, but in general, we're trying to get m equals a value. So let's start with distribution. Negative 4 times 4, negative 16. This one, negative times a negative. This is positive 28m. So now I want to rewrite the right side. And now I look and see that I have like terms, but they're not on the same side. For example, 28 and 5. These both have an m on it, and I'd like these to go together. So if I have 28 on the left and 5 on the right, I could just knock these 5 off and reduce this one by 5, and that balances the equation, if you will, kind of like what you'll do in chemistry. This preserves its truth. For example, like 2 plus 3 equals 5. Well, I could minus 1 minus 1. Well, 2 plus 2 equals 4. See, that preserves the equality because I did the same thing on both sides. So I want to keep going. I want to put the 16 and the 30 together. Those are like terms, but because it's negative 16, that really makes it more like subtraction. So the opposite would be to add that value to the other side. 23m equals 46. Well, now I'm really close to my goal of having m equals a number. And again, when you see things that are against each other, that represents multiplication. So let's do the opposite of that and divide to understand that it's 23 times 2, that's 46. So we need to plug 2 back in on both sides to test it, and I'll let you do that if you'd like to see that both sides are equal to each other when you plug in 2. So you try 12 on your own. We talked about this a little bit in class, which is not a function 1, 5, 1, 6. These have repeating x values. You want each input to be unique for it to be a function. To do that graphically, we can draw a vertical line across or on top of a graph, and if it was to cross 2 times, that would reveal that we have repeating x values similar to the top problem, meaning it's not a function. But this graph, each of these x values only has one corresponding y value, and that's why it is in fact a function. Function notation, if f of x equals 3x squared minus 2x, what if you plugged in negative 4? So important that use parentheses when you're squaring negative numbers, especially in the calculators that I provide in class. So I've got 3 times negative 4 squared minus 2 times another negative 4. And so this is going to come out to be, one second, I noticed that I did not use a minus sign. That is going to be a problem. Let's see, that should have been a 2, and that should have been a minus. Sorry about that. So that all gives me 56. So I'm going to work through that. Negative 4 squared, that'd be positive 16. Multiply that by 3, you get 48. These are multiplying to be positive 8, which is calculating to be 56. With the order of operations, we really got to start with that parenthesis. All right, I want you to try the last few. I'm kind of running out of time. Hope you have a great night, and I will catch you next